Good morning, everyone, and welcome to the Cative Autodesk Virtual Academy, your once-a-week learning webcast for all of the Autodesk software you and your team use every day. Today, we've got special guest here, Wayne Griffenberg. This is actually Wayne's second webcast for us. Good morning, Wayne.
Good morning, Nigel. Good to be here.
Yep, and I guess it's good afternoon for Wayne. So Wayne's on the East Coast. So as you can see here, Wayne always wears his safety glasses, ready for any machining at any time. But today we're going to go over 4 and 5 axis toolpaths. You might ask why we're going to jump straight to 4 and 5 axis, maybe not 2.5 or 3. And that's because we've already done a couple of webcasts kind of highlighting some of the 3-axis toolpaths and the capabilities of Fusion 360 specifically. And we've received a lot of interest in going to things like multi-axis contours or swarfs and things like that within Fusion 360 Ultimate, or even just the HSM tool and Inventor itself. So we're going to answer some of those questions today, and hopefully we can have a great time doing it. So Wayne, do you have anything to add to that?
Nope. Yeah, we're going to walk through some simultaneous stuff and talk about the differences between the standard product and what's in Ultimate. But I think as we go through, if you guys have any questions, you can add them in the chat or in the questions panel. And I think Nigel's going to monitor some of those questions.
Certainly.
And please feel free to ask, and I'll be able to get an answer for you.
Certainly, and even if they're not related to the topic at hand, go ahead and ask any Autodesk-related questions. And if they're not applicable to the webcast, I can follow up with you afterwards. If there's something pressing on your mind, something's crashing on you, or you're getting a weird error message, let us know. We can certainly get the right resources to you after the webcast if need be. Yep. I know we've had a lot of people do that before in the past, and it's been a good experience. So with that, I'll go ahead and pass it on to you, Wayne, and let's go ahead and get started.
Awesome. Thanks, Nigel. Okay, so I'm going to walk through today with you guys and talk about Fusion Ultimate. So this is going to be a quick overview. I like to think of these as training. So as we had mentioned, if you have any questions, please feel free to ask. I'll do my best to get an answer. And if I don't have an answer, we'll get one for you. So I'm going to walk through this overview. I'm going to point out some of the differences between the standard product and the Ultimate product. And just as you know, the Ultimate is where you can get your 4th and 5th axis toolpaths. If you're doing indexing, probing, getting live, or shall I say simultaneous 4th or 5th axis, it's all in the Ultimate product. Okay, so today we are going to walk through the process. We're going to go through and draw up a part. I'm going to revolve a model, and I'm going to show you how to get some 4th axis pockets in there, if you will, some wrapped pockets and some holes, and we'll do some indexing. And I want to show you how to set it up for your orientation as if you're going to make it on a rotary machine. And we're going to apply some 4th axis indexing and simultaneous. We're going to simulate just to check and make sure when we make patterns that it's going to do what we expect it to do. And that'll help us to verify that our toolpaths are going to work on the machine. And we're going to post-process on the G-code. And I'm going to show you as we walk through that we are getting the indexing and how that looks in the code. We use a Haas machine, so I'm going to walk through the Haas post with you. Make some design changes. We're going to change that part and show you how the toolpaths are updated through our completely integrated CAD and CAM interface. And afterwards, we'll look at some questions and maybe even dive into a little bit more of the toolpaths as well. So the part we're going to work on will look like this part. As soon as I can bring it up, a simple little, it's an adapter housing or adapter bracket for the bottom end of a vacuum cleaner. A simple part, and we're going to add some toolpaths, which will end up looking like this. So then we're going to wrap those toolpaths around the part, and we'll show you how to do that and how we output those toolpaths for indexing. Okay, so I'm going to bring up my Fusion product here. I'm going to go into a project, my Fusion Ultimate project. So when you guys start working with Fusion, you're going to start to see projects that you have filled up. You can share projects. You can do this on the web-based interface. And any of the components that you see in the Fusion project, you'll see the version. Each time you update them, you can always go back in time and see the different version. Here's one part we use for training on 4th axis wrapped, and I can see all the version history here. But today I'm going to start a part from scratch, but we're going to walk through some of these components so we can show you the Ultimate product. Okay, I'm going to start to draw one up from scratch, but this is going to be my modeling interface. We're going to mainly spend time between modeling and CAM. We do have the other workspaces that come with the standard product as well as the Ultimate product, which is our patch when you're working with surfaces, rendering to get your ray tracing and your photorealistic versions of your parts or assemblies, animation so you could show your customers or your colleagues how your part works or your assembly works, simulation, so it's full Nastran engine that works inside of Fusion to be able to do your simulation, your stress strain analysis, fluid flow. If you do have Ultimate product, you have a lot more static as well as dynamic simulation that you can do. We're going to spend some time here in CAM and show you some toolpaths that we can put on and what the differences are between standard and Ultimate, and of course drawings. You can get your full drawings of your components for your customers or your colleagues. Okay, so this is our interface. So I'm going to work through the model. So I'm going to expand down my origin a little bit. This is my browser. I'm going to parametrically design the part using Sketch and Create and Modify. Just to let you know, we can create components from primitives as well as being able to make form. So you can actually stretch and mold your model, push and pull. We're not going to get into that too much today, but we are going to extrude and revolve some different components in here. So I'm going to make a rotary part. And so therefore, it's going to be going around my x-axis. So I want to be able to design it in such a way. Now, you don't always have this opportunity. A lot of times when you're working in your shop, you don't really have access to the part to be able to change it or design it the way you need to. But it's always good to know that you can orient it into position for machining. In this case, I'm going to rotate my part. Since I do have full design, I have my napkin sketch sitting here. So I'm going to rotate a tube around the x-axis. So to do that, I want to be working in my XZ axis. But notice as I hover over here, I have the different axes themselves as well as the planes, the XZ, the YZ, and the XY plane. So it's an easy way to remember for those of you who are new when you're working with Fusion, especially when you're working with machinery, XYZ, RGB. It's an easy way to remember which the axes are. And I can also see on my view cube, as I move it around, I can grab this view cube and I can move around. And I can also see the axes on the view cube itself. But so I'm going to make a revolve around the x-axis because that's going to be my rotary axis. So I'm going to select that plane, right click, use my marking menu, I'm going to create a sketch. And it moves me into the sketch. Now, if I roll out with my middle mouse button, you start to see the number line update. Give me an indication of how big the part will be as I stretch a line, or at least my geometry is going to be. So I'm going to make a rectangle. I'm going to hit the R key to start the rectangle command. You can also go up onto the sketch panel here and go down to rectangle and choose 2-point rectangle. So we do have those quick keys that you can use to start the command, the rectangle command. And once I start it, you see that attachment right at the bottom corner of my cursor now. So, and it also brought up my sketch palette when I started working in Sketch, and we have different constraints that we're going to work with as well. So I'm going to select the origin, and as I hover over, you see it snap that box on the origin. And if I start to drag away, you see it rubber band these dimensions as well. So my part's going to be 3 inches in diameter. Actually, yeah, it's going to be 3 inches by 4 inches long. So I'm going to start with my radius here because it's going to be 3 inches. I'm going to make it 1.5 inches in diameter. And I'm going to hit the tab key, which will lock in that dimension and now move me into the length dimension. I'm going to make that 4 inches long, hit tab again, and now I'm locked with those dimensions. So if I switch to different quadrants, it locks me into that dimension mode. I'm going to do it in this quadrant, so I have a positive Z. I'm going to click in that quadrant, and now I have my fixed sketch. I'll hit escape to get out of the rectangle command, and now I have a 4 by 1.5 inches rectangle. It also applied constraints. These are the horizontal and vertical constraints automatically applied because they're horizontal lines and vertical. And also all my lines in my sketch are black, meaning that it's confined or it's constrained. Now, I don't really want this to be a solid block. I want to make a tube. So I'm going to turn these into construction lines. All I did was put a box going from left to right, highlighted all those lines, and up here it opened up normal to construction. I'm going to turn them into construction because they're just going to be guidelines for my tube. Now I'm going to add a rectangle going from this corner down, and this is going to represent the cross section of my tube. Okay, I can plug in the dimension. This is going to be 3/8 of an inch. And now I have a 3/8 of an inch rectangle, and I have a distance to the center. So I'm going to revolve this around the center, which is my x-axis. So now I'm going to stop the sketch. I'm going to go up to Create, Revolve, select that region that I have made, and now I'm going to revolve it around an axis. So if I select axis, I can choose my x-axis or my center line. I'm going to choose the x-axis, and it revolves the body around. It knows we don't have any other features, so it made a new body. I'm going to say OK, and now I have the basis for the starting of my tube that I'm going to use to put some 4th axis toolpaths on. Okay, so I'm going to use the same plane, and I'm going to actually use this plane to make some offset planes, because I'm going to put a geometry pocket on this side, and on the other side I'm going to put some holes. Okay, so I'm going to, while I highlight that plane, I'm going to construct, I'm going to offset a plane in this direction, and I'm going to make it 1.5 inches. Negative 1.5. So I made a plane just by grabbing this plane, moving it over, so I can actually sketch on that plane and project into my model. I'll do the same thing while I'm here. I'll make another plane, and I don't have to go up onto here. I can also right-click, and I can go up and say repeat the offset plane. And I can also go up here and get sketch. I can also do construct, and I can do the offset plane here as well. So there's a lot of different ways that you can get to your construction and get to your sketch items as well. So I'm going to select that plane again. I'm going to stretch it over here, and again I'm going to make that 1.5 inches. So now I have 2 planes on either side of the part that I can start to draw on. And let's do that. So I'm going to make a pocket on this side of the part. So I'm going to select this plane, right click, create a sketch, and now I'm just going to make some pocket feature over here that I'm going to project onto the model. So I'm going to start with a rectangle again. I'm going to hit R for rectangle. Before I do, actually, I want to put a center line that'll make it easier for me to add symmetry for my pocket. So I'm going to add a line. I'm going to hit the L key on my keyboard to start a line. I see it attached to my cursor. I'm going to click the origin and drag it over. Now I could choose to project that back line in here if I want to keep this model updating, so as the model stretches, I can also stretch my line as well. I can also put in a finite dimension in here also. So let's do that. I'm going to put 4 inches just for this case here, and that's going to be a center line. So I'm going to select the line and then make it become construction. Now I'm going to add a box. I'm going to hit R for rectangle, and I'll add some box around here. Now I do want to put some features on the front here, so I'm going to stretch this box back a little bit, but it's really kind of floating around in space here. Now I want to add some fillets around my box, so I want to go up to the fillet command, and if I hover over a corner, you see it wants to give me a preview of the fillet. So if I click, then it lets me change the fillet size. I'm going to make this fillet 3/8 of an inch. Okay, now I'm not going to hit enter or anything. I'm just going to work my way around to the other corners to apply those same fillets around the part. Now that I'm done, now I can hit enter and it applies the fillets, and I can control it in one place. Now I want to add some symmetry about the center line for this part before I put a dimension. So I'm going to go down to symmetry. The 2 lines that I want to be symmetric about that center line, and now it made them symmetric. I'm going to hit the escape, and now if I drag it, you see it'll be symmetric about that center line. Now let's add some dimensions to confine it, or to define the box. So I'm going to hit D for dimension, or you can go down here and hit sketch dimension D. So I'm going to hit D, dimension from here to here. I can also dimension to the center line as well, but I'm going to dimension the overall width of the box, of the pocket. And that's going to be 2 inches in height. And it kind of shrunk it down a little bit, so I'm going to drag this back a little bit, like this. Okay, and now I want to make that the overall length. I'm going to go into put a dimension for the overall length from here to here, and I'm going to make that 2.5 inches. And now I want to put a dimension from here to the back of the part. So as the part stretches, so will the pocket move. So I'm going to also make that 1/2 inch from the back of the pocket. We're going to add some other features over here. All right, so there I have a pocket And what I want to show you is how to project it to be able to make it a wrapped pocket on the model. So I'm going to stop the sketch. My sketch is fully defined. So if I look at it on the side, I sort of have this rectangle kind of hanging off the side of the part. What I want to do is I want to project that rectangle onto this face and split the face. So I can then push pull and make it a wrapped pocket. So I'm going to go into create. Actually, no, I'm going to modify. Sorry, guys. I'm going to go to modify, split face. And it's asking me what face do I want to split. I select the outer diameter of my tube. What's my splitting tool? It's going to be that geometry. And it looks at all the places where it can combine with the model or cut through the model. I don't want to go all the way through. I just want to split the face. So I'm going to say closest point. So what it's going to do, it's going to project wherever it's closest to my geometry. And it's going to split that geometry on that face. I'm going to say OK. And now I have this split geometry right here on the face. So I can now work with that split geometry and I can use that as a feature that I want to extrude through the model. So now if I go to modify, if I grab that face and now I can push pull, it looks like I'm going to actually extrude a body there. It's just a way that the Fusion kind of depicts it. But if I extrude it all the way through, and I know negative 700 thousandths is a lot, but I know it's bigger than the width of my tube. So if I say OK, it automatically recognizes it as a cut. So now I have a cut wrapped pocket going into my part. So this is a little bit of a tip and trick on a way to be able to get a true wrap pocket into your model. Okay, so I got a wrapped pocket there. I'd like to make 5 of those around my part. So what I'm going to do is I'm going to take that wrapped pocket. I'm going to make a pattern out of it. So I'm going to go up to create, pattern, a circular pattern, and it already selected the face because I selected it ahead of time. And now it's saying, what do you want to wrap it around? What axis? I'm going to choose my x-axis right here, and I want to make 5 of them. So now I think I did my pocket a little bit wrong, so I'm going to go back and make a change, but that's okay. I made 5 of these pockets, but I left little room for me to put some 1/4-inch holes in the middle of there. So I think my pocket should have been like 2.5 inches instead of, or 1.5 inches instead of 2. So that's all. That's okay. I can easily go back and make a quick change. So if I go back in time, I can see my sketch. I can see before I put that wrap pocket in there, that wrap. I can edit this sketch, and I don't really have to go back in time. I just want to show you we can do that. But now if I go to edit this sketch, I can right click, edit sketch. I can always go back here and make that 1.5 inches in height of the pocket, stop that sketch, pull this back through time, and now we have 1.5 inches pocket. I'll give it a second. It's going to catch up with me here. Come on, let's go, Fusion. Yeah, it'll take a second. Sometimes it takes a minute to calculate. And hopefully it's not going to crash, but if it does, I can always get back here really quickly. That looks a lot better. So that's actually what I'm looking for, because I want to put some 1/4-inch holes around here. It's going to add some stability to my design as well as make it lightweight. So that looks pretty good, and I like the flexibility of being able to go back and make some of those changes. Before I go on to the next step, that freeze up there made me think about saving my design, because if it crashes, I lose everything. So I'm going to go up here to save. It's going to save in the last project where I was working, and this one I'm going to call it adapter. So I'm going to save that adapter in this project. Okay, so now it's saved. I know if I go back into my data panel, I can see that adapter right here. So now I'm going to add some holes to the other side. I'm going to show you how to index those holes when we're done. All right, let me, all right, looks like my 3D mouse isn't going to cooperate. So I'm going to hold Shift and my middle mouse button to rotate the part around. Okay, so I'm going to add some holes on this side. The reason I made this plane opposite of that plane, because when I made 5 of these, I know this plane is going to be normal to this face, so I can add some holes in here. So I'm going to go up and add a new sketch to this plane. Okay, I'm going to add another center line, so I'm going to hit L for line. I don't think that hit the center. I'm going to drag it off, and I'm going to make that also 4 inches long. and I want that to be a center line. So I'm going to change the line to construction. Now I'm just going to add a point. So I'm going to go to sketch, point. I'm going to add a point along the line. Now I want to pattern those points. Right now I kind of put it arbitrarily along the line, but I want a pattern of 5 of them. So I'm going to create a pattern. I'm going to go up to sketch, pattern. Oh, where am I here? There we go, rectangular pattern. And now I can put in, I want 5 of these. So I'm going to have 5 holes. And I can start to stretch this along, and I can see the dimension. I get a preview of where it's going to put that pattern of points. I can plug in a dimension. I know that I want this to go 2.5. And I can hit OK, and it made a pattern of those points really quickly. Okay, so those are going to be my holes. I want to control where the first one goes, so I'm going to hit a dimension. I'm going to dimension from my center point back, and I'm going to make that 1 1/8. It looks like it's a little offset. Let's make it 1 inch. There we go. So now I have a pattern of holes, and I have it going 1 inch back into the part. So I'm going to say, this is actually just a pattern of points, but I'm going to make them into holes. So my next step is to do that. Let's make them holes. So I'm going to choose my hole command, create hole. Okay, I'm going to select one of these points, and it makes this giant hole here, which gives me a preview that's going to cut all the way through my model. I want that to be 1/4 inch in diameter. And I don't want it to go all the way through because it'll cut all the way through my tube here. What I want to do is I want to have a distance. I'm going to choose 2, and I can select this edge, or I can select this face like that, and it's going to go through that face. I want additional holes, so I just simply go in here and select the additional points. And now I have 5 holes, 1/4 inch holes along that plane. I'm going to say OK, and now I have 1/4 inch holes going through that plane. Now I'd like to make those a pattern as well. So if I highlight the holes, go up to create, oops, I went into form. I didn't really want a form, so I'm going to undo that. Yeah, I'm going to undo again because my clicking is too quick. So I'm going to go in, while I have it highlighted, I'm going to go up to create. I'm going to go to pattern and a circular pattern. Again, it selected the hole features, and my axis is going to be the x-axis, and now I have 5 sets of those holes going around the part. Now, looking at the time, sometimes I like to put another feature in here, but looking at the time, I'm going to kind of walk through what we have here and show you how to index and get the 4th axis simultaneous pockets. So far, are there any questions that come in that I can answer? If there's anything pressing, I would like to jump in. Right now, I'm just working in Fusion, making a model. I haven't really gotten into the CAM yet, but if I can answer anything, let me know.
Yeah, there's some general questions here real quick. If we just want to go over this one. Can Fusion pull in and modify Mastercam G-code? That's one.
If you can say it again, can you bring in Mastercam G-code?
Yeah, can you bring in Mastercam code and then modify it from there?
Mastercam G-code, no, we're not able to bring in any G-code from an outside source. Even our own G-code, there's no. Oh, let me answer this again. Maybe I'm misunderstanding the question as in modeling, because my mind's thinking of modeling. We can, in our editor, open any G-code, and you can edit any G-code through our editor. That's not a problem. I misunderstood thinking, could we recreate a model, or could we do a toolpath from G-code? That we can't do. But yes, we can open up G-code and edit it and change G-code in our editor.
Okay, so that should answer that question. Glenn, if you have any further anything for that particular question, let us know. And then just real quick before we move on here, Wayne, how can I determine if my Fusion is Ultimate or Base?
Okay, and you should be able to go into your Autodesk account. And if you go into your Autodesk account, I'm going to log into mine real quick, so you can see all the wonderful programs that I have working with Autodesk, which is awesome. But when you go into your Autodesk account, when you get Fusion, if I go down to Fusion here, it'll tell me right here if I'm working with Ultimate or if I have Standard.
Yep, and if you have any questions on how to access this, Maybe you're not like a named user in your account. You might need your contract manager to check this for you. Go ahead and give us a ring or something, and we can help you figure out whether or not you have an allocation to Ultimate, or you just have regular Fusion as part of like a suite or a collection or something.
So this is that's actually good that we're going to switch over to the CAM side now, and I can actually show you some of the things to look for whether you have standard or ultimate. So I'm going to save this again with the holes. I'm going to say added holes. It's always a good idea to let people know on your team or your customer when you make changes, because it changed the version now. So I'm going from version 1, and when that update is done, I'll go to version 2, and I can see the history. So 10 seconds ago, I added holes. The previous version doesn't have any holes. So I can always go back to any of those versions and work with it, but it's a good idea to keep that information so you can quickly see when you made changes to your model. So it's really helpful every time you save to really add that info. So I'm going to switch over to the CAM interface now. I'm just going to turn off the origin because I don't want it to be confusing when I go to set this up. So I'm going to actually switch over. I'm going to go from model to our CAM interface. And now I'm going to explain a little bit of what you'll see in the differences between standard and ultimate. So this is our CAM workspace. And in the workspace, we have all the tools that you need to be able to make your parts. From setup, going through the different types of toolpaths, and then our managing our libraries. When you have the standard product, you'll be able to use all the 2D toolpaths. We actually call them 2.5D toolpaths. You'll be able to work with these. You'll have the 3D toolpaths that you can work with, and you'll have turning toolpaths where you can do your lathe programming. You won't have, in the ultimate product, multi-axis. You won't have the swarf toolpath, the multi-axis toolpath, and in the very near future, the blend toolpath. It's not there yet, but our developers are working on getting that out soon. So you'll have multi-axis toolpaths only with the ultimate product. Another thing that you'll see only in ultimate is under setup, the probing. We can run probing, especially works very well with Haas and Datron and Tormach machines. So far, we have a lot of different machines we work with, but it's really adding the code to the post to automate the process for probing. You won't have this with the standard product. This is only going to be with Ultimate. And in a few minutes, I'm going to show you about indexing. So we can get indexing. We can apply a 2D or a 3D toolpath to a part. But the way we do the indexing is through the toolpath, and I'm going to show you in a minute, but through the toolpath, we have a function here where it says tool orientation or wrap toolpath. You won't have access to tool orientation because this is the secret, I shouldn't say secret, well, it's a secret recipe, but this is what you would need to be able to do your orientation or your indexing. Okay, and we're going to show you how that works, but this is something that you would only find also in the ultimate product. Okay, so just to let you know, the difference between the 2D and 3D toolpaths, 2D require to drive the toolpath 2D geometry, like splines, lines, arcs, and points, 2D geometry that you can find off of sketches or on the model itself. But it's usually planar geometry that you're selecting which will drive the toolpath. That's what makes them 2D. 3D toolpaths respect the model. They require the surfaces, faces, and edges of the model itself to drive the toolpath. Like I said, they respect the model really well, and it puts the tool everywhere it can go efficiently without gouging the model. I'm not saying it doesn't. I'm saying our toolpaths do a great job of respecting the model, and you could set them up to make sure that you're able to stay clear from any places on the model or the stock. Then drilling, of course, is with all of them. So drilling is basically your drilling holes, your hole making. And you'll get that with standard and ultimate. And then, of course, turning, 2-axis turning. And if you combine 2-axis turning, and let's say you have a Y-axis machine, you can do all your turning toolpaths. And when you're ready to do the milling, if you're doing like live tooling, Y-axis drilling, you just simply go over and do a drill toolpath and choose the tool orientation. And that's where you get your multi-axis rotary on your machine, on your turning machine, your milling, your mill turn, if you will, live tooling. But again, you'll need ultimate to be able to do that. Okay, so With that, I'm going to set this part up. Make sure I'm oriented the way my part should be. I'm going to rotate around the x-axis. That's the center axis of this part because I drew it that way. But if it's not, I want to make sure I orient the part that way, and I can always do that in setup to get the right orientation. In this particular case, I drew it that way. So the first thing I'm going to do is orient it the way it's sitting in the machine. Okay, my Z will be up, and I'm going to have it oriented like this, sitting in the machine. So I'm going to go to Setup. Right now, it's by default on milling. My operation type is milling, but it's okay. You can have milling, you could switch over to turning or mill turn, or cutting if you're doing plasma jet or laser, or I'm sorry, plasma, water jet or laser. It's always the same workflow in our CAM. So there's no extra modules you have to add. It's just a matter of changing your workflow. And it's exactly the same throughout all of these. So in this case, I'm doing milling. So it expected to see like a rectangular type part. And that's okay. The first thing I want to do is I want to set my tube part stock. So I'm going to go over to the stock tab. It doesn't matter if my orientation's off yet. I'm going to show you how to fix that. I'm going to go into my stock tab, and I could choose whether I want a relative size box, a fixed size box where I can plug the numbers in directly, or I could choose a cylinder, a fixed size or relative size cylinder. Relative simply means it's going to recognize the size of the model itself, and it allows you to add some excess around the model. So I could do a fixed size tube or a relative size tube. In this case, I'm going to choose a relative size tube. It recognized now that my Z was up because it knows I'm doing a milling operation. It wants to put the Z up, and that's fine. But I don't have the axis of my part. My tube doesn't have to be around the Z. So if you bring in a part and it doesn't happen to be in the right axis, you can simply choose it. You can choose, let's say I want to choose this center opening or the ID of this tube. If I select it, it now shifts it around, recognizes the tube, and it adds this offset 40 thousandths above and below the tube. So it automatically recognized the tube geometry and added some material around it. Now you don't have to do it as a relative. I could do a fixed size box and just simply plug in the exact numbers. So that's got my tube. I'm going to add, let's say, 50 thousandths around it. So I made it a little bit thicker, and you can see it grow right on the model. Like let's say I added 100 thousandths, you'll see it grow on the model. And that's one of the great things is if I change it here, I see it graphically. So I don't have to wonder if I've actually added stock around the part. I can see it happen directly and graphically. So I'm going to add 50 thousandths around the part. And now that's on the inside and outside of the tube. And now I'm going to go back over to my setup. I don't want it to rotate around the X like this because it'll be quite wobbly going in my rotary machine. I want my X to be along the center line of the part. So I'm going to change this. Instead of being at the box part or stock box point, I can choose a stock box point in the center of the part if I wanted to, like this. Or in this case, I can choose my model origin, which happens to be the Z, X, Y, and Z at the center in the front of the part to rotate around. So there's a lot of different ways that you can orient the part to get the right rotation. So for fourth axis indexing, this is what I want to do. I want to set the X-axis rotary right in the center of the part so as it rotates around, I can position any of these pockets or holes to position it to the tool coming down in Z to machine any of those components. Okay, so it looks like I'm pretty well set up. I got my stock, got my orientation. I'm going to say okay, quickly and easily. Now, the first thing I want to show you is setting up these holes. If you notice in my setup, my Z is not completely aligned with the holes. My Z is sort of like up in the middle edge of this pocket right here, right? But that's the way it's sitting in the machine. I'm going to reorient this around, so I want to be able to get those holes. And that's where I'm going to use my indexing. I'm going to index it for each of these holes. So the first thing I want to do is I'm going to go in to do a drill tool path. I'm going to go to drilling. And I'm going to select the tool. Now I kind of forget, I know I made those holes just a second ago, but I kind of forget what size they are. If I hover over a hole, it tells me. Fusion gives me feedback and says, oh, that's a 1/4 inch. In fact, any hole that I hover over, even this inside diameter will give me what the diameter is of that arc. In fact, even in the corner here, I get that as well. So this is a 1/4-inch hole. That's a nice feature of Fusion. I love it. So, and it's actually part of our cam that does that. So it's a 1/4-inch hole. So I'm going to grab a 1/4-inch drill out of my library. I highly recommend creating a library that matches your machine and tools in your machine. I'm going to scroll down, but you see it filtered on hole making. It knows we're making a hole, and it filtered on tools that make sense for hole making. Now I can filter even more, and I'm going to go into dimensions, and I'm going to filter down on 1/4-inch holes. Choose a diameter, or I'm sorry, 1/4-inch drills. And it filtered down on all the 1/4-inch drills that I have access to my libraries. I'm going to scroll down a little bit because I created libraries for my Haas machines and for my Tormach machines. I don't think I have any 1/4-inch drills in my UMC or my VF2, but I have some for the Tormach. And these come with our library. But again, I highly recommend creating a tool library that matches your tool crib or what's in your different machines. So in this case, I'm going to grab this 1/4-inch jobber drill. I'm going to say OK, and I can see the drill in the preview. I could see it in my graphics view. And I know that drill's not going to come down to cut that hole. I need to rotate around a little bit to drill that hole. So here's what we do. In the geometry tab, when you have the ultimate product, you'll have this tool orientation function that you can enable. If I enable that, now I can rotate that Z to match my geometry. So if I have the Z-axis here, I select that hole, it flips the Z. Now the Z went upside down only because the vector of the hole is going upside down. If I just simply flip the Z, now I have the Z oriented in position to be able to drill that hole. In other words, I'm going to get code that's going to make my machine turn some 15 degrees, whatever it's going to be. My machine's going to rotate, and now I'm going to be able to come down in Z and get those holes. And this is how you do it, tool orientation. And again, you need the ultimate product to be able to do this. Okay, so now I want to select the hole. So I go up to hole faces. I'm going to select this hole. And now it knows that hole is normal to my Z. And if I had let's say I had one of these tubes, let's say I have a pipe that has 65 holes in it, and you're thinking, man, I got to grab every one of those holes. That could be tedious. Well, you can also select the same diameter function right here, and it grabs all the same diameter holes in the same plane automatically. Really quickly and easily, you're able to get your holes there. Now, one thing I noticed too, if I hold it to the side, those drills aren't going all the way through my hole. The tip is only going down to the bottom where the surface is. If I go into the heights, I have a function where I can change the hole bottom. I can stretch it down if I want. I can also drill the tip through the bottom, and I can add an offset, let's say 20 thousandths. Now I can look and I can see that the drill is going all the way through the hole, and I added that extra breakthrough depth. Okay, we have lots of cycles that work well on the Haas machines. We have chip breaking, which is your peck drilling, which will give you your I and your J and your Q values. Counter boring, deep drilling, guided deep drilling for gun drilling, tapping, boring cycles, reaming cycles. I'm going to leave this as a regular drilling cycle. We're not going that deep. So I'm going to leave it like that and hit OK. So now we have a drill cycle. Right, so we rotated from our initial setup position. We're rotating around to get that drill cycle. Now I want to show you the code real quick so that you can see. I'm going to use my Haas A-axis post, and I want to show you what that rotation looks like. So I'm going to go and post out. So I go up to post process. I'm going to go in here to my generic post. Just to give you a reminder, we have lots of posts that come with our Fusion and any of our HSM products. And these posts are generic. They're not encoded. You can always go in and make edits. I highly recommend making a copy of it, but you can always go in to edit your post. They're all JavaScript. And we do have a post online library where you can find different posts so you don't have to edit yours. If you go into that online library, you can do a quick search by vendor, different machine vendor, or different types of post, and you can see that we update them very often. The generic Haas that works well with the VF machines and the TM machines was just updated 9 days ago, and we do a lot of regression testing with all of our toolpaths. We work directly with Haas to make sure that we have the latest post, and it's updated with all the latest functions. So being a Fusion user and being in the Fusion community, you get updates in Fusion every few weeks. You're also going to get an update of all the generic posts as well. So you'll have the latest posts. You can do a search and find your post. If you are going to edit your post and you do need help with that, you can always go to our forums. Go to our Autodesk. I'm going to go to our main forum. Here's our Fusion forum, but I like to go to our CAM main forum. If you go to the Autodesk CAM, it's up here. It'll link us over, forums@autodesk.com. You can go to any of our forums, but if you go into the CAM forum, HSM, we have a post processor forum here. So if you need help with your post, or if you're looking for a specific post, I highly recommend going here first. Go into the post processor forum, and it comes up. We have our elite users who are here every day, power users, as well as our Autodesk post developers are here, and they check every day in this forum to help people. You can see people looking for specific types of posts or help with their posts. We have our Post Processors 101. We have getting started, your post processor manual. So if you want to learn in JavaScript how to edit your own post, this is a great place to learn. And also, if you're looking for a particular post, you can search for it right here. And I'm sure that somebody in our community may have worked with that post already. They can help you out. And being a community-based forum, a lot of our community is able to help support. And if they have a post for the same machine, they'll help you. They'll give you that post. We also have editors in here who can help you edit. Sometimes, we may have some that will charge for, like, if you have, a 7-axis machine that has, unique custom axes and certain tools. It might be a quite a large edit to do. It might take a long time. Where you might want to find some resellers out there who would charge for such post. But for most simple post, if you're doing mill turn, if you're doing your 3-axis machine post, we generally can find them in here pretty well. Okay, so this is a great place to search when you're working with post, if you want to start learning, or if you're looking for a particular post. And you can always search our online post library to make sure you have the latest. If you do have any custom posts, put them in your personal post file. If you put them here, it's in your users. If I switch over, I can see it's in my app data. If I put my personal post here, they won't be overwritten when Fusion's updated. Only the ones in a generic post get updated. Okay, so in the generic post, I have a Haas post with A-axis. So if I go down and look at my Haas with A-axis post right here, so that means I have an A-axis either on a trunnion or a table. So now when I post out, I'm going to get that A-axis call. I can choose some other places in here if I want to, preload the next tool, choose some optional stops, sequence numbers. You can turn on G187 or use G28 versus G53. Turn on your radius. You can get I, J, and K versus R values and so forth. I'm going to leave everything the way it is and then post out. I'll overwrite the post I had earlier. I already posted out, the code that I'd posted out earlier. And now I get this code for the rotary machine. So now I get my lock code G54, unlock, rotates 18 degrees around, relocks, turns on coolant, and now I get my code to be able to do the drills. And then it returns back to the 0 position, locks, unlocks, 0 position, and then we move on to the next stage of getting ready for the next toolpath. So my code's going to show me in the Haas, and I'm going to get that 18-degree rotation. Okay, so now I have these other holes that I want to do. And of course, I can easily go in and I can right-click and I can copy that same toolpath. I can paste that same toolpath. So I have a duplicate of the same drills. Now, if I edit drill number 2, and if I go into geometry, I'm going to change my Z-axis. Instead of being this same orientation, I'm going to change it to this orientation. Now for my hole faces, instead of these holes, I'm going to choose this hole right here. And since I used the same diameter technique, it found those same holes here as well. I think it also included this one. So let me clear out those hole faces again. It says nothing. My orientation should be okay. And I'm going to choose this hole. Now it looks better. For some reason, it stayed blue here. I guess it was graphical. Okay, now if I hit OK, now I have a set of new holes. Now I have that rotary motion, right? So I'm indexing from this position to this position. And of course, if I post out both of these, and now you'll see the first one, there's the A18. And now in the second one, we're going A90 degrees for drill number 2. And then we're returning back. Now you can think, well, I can do that. Now I'm going to copy 5 of these down, and what if I have different holes and so forth? It could be a pain. Well, here's another way you can do this in a nice way. I'm going to delete out the second holes I did, and now I'm going to make them into a pattern. So when I highlight that toolpath, I go up here to pattern, and I can do a linear pattern of those toolpaths. I can also do a circular pattern of those toolpaths. What is my axis? Well, I can choose this center of the part, and I want to make 5 of them. So now I can pattern toolpaths around the part. Okay, and now I have a pattern of all of those holes going around the part, super quick and easy. And now if I want to check the code, let's go and post out. I'm going to highlight setup, post out the code, save it. And now if I look at my A, let me go up here, there's my A18 for my initial hole, and it's going to hit find next on this one, F3. Now, there's my A18, right? And now if I go down and I look, I'm going 90 degrees, my 162 degrees, 234, 306, now I'm back to my 0 point. So it automatically gave me the rotary call as well as, the lock unlock codes to go to each position. So I just simply set up a pattern of those same holes. Okay, guys, I'm realizing that I talk a lot, so I'm well into the hour. I want to be able to get some time to show you doing the simultaneous fourth one here. So I'm going to go into this pocket, and we're going to set up a simultaneous fourth axis on this pocket right here. So I'm going to go up into 2D. Yes, I'm going to use a 2D toolpath, not a 3D or multi-axis. Our 2D adaptive clearing, which is a great clearing toolpath, really good for keeping the tool engaged and using as much of that flute length as possible. The adaptive clearing, our 2D pocket, and 2D contour all have the wrap toolpath function inside of them. So if I did a 2D adaptive clearing, right, and you can only get this with the ultimate. So I'm going to do the 2D adaptive. I'm going to, again, working from left to right, it's always the same workflow. So working from left to right, I'm going to select the tool, and I'll use a 1/4 inch rougher, right? So if I go into end mills, I'm going to get a flat mill. So I'm going to filter down on flat mills, and I'll get a 1/4 inch flat mill out of my sample library. 1/4 inch will work. And now if I go into my geometry tab, if I go to select this pocket, let's say I select this pocket right here, it projects it into a 2D plane normal to the Z. That's not really wrapping it or anything like that. If I go and I see this function right here, wrap toolpath, and I enable it, it now recognizes the fact that that pocket is going to be wrapped around a cylinder. It has to be a cylinder. It can't be a cone. It can't be a wavy shape. It has to be a cylindrical shape for this to work. So I have my wrap. It's asking me what my wrap cylinder is. I can select this outer cylinder or inner cylinder. I'm going to select the inner cylinder, and it now projected that geometry onto that cylinder. Okay, so since I'm doing a 2D adaptive, I'm going to make some changes. I want to make sure now everything is still like a 2D, but it's wrapping it around that cylinder. So I want to make sure that I'm able to go below the pocket here, because I did add, I think, 100 thousandths, or was it 40 thousandths on the bottom? So I want to make sure I go all the way through. So I'm going to drop this 100 thousandths below where I selected the geometry. Oh, no, I want to go 100 thousandths, not an inch. Okay, and so I'm going 100 thousandths below. I can change my optimal load. How much do I want to have that tool with a constant engagement in that material? I can change that here. I'm going to leave it out of the box. And I'm going to leave some stock because I'm going to come back and do another operation. So I'm going to say OK, unwraps and rewraps, and now we have a true wrapped fourth axis adaptive clearing. You can see it's using that fourth axis code here as it helixes in, and we have a tapered helix getting down to the bottom of the pocket. Once it reaches the bottom, and it's good that we use a tapered helix because it helps those chips to get pulled out each time it passes around. So you're not recutting those chips, you're not work hardening by the time you get to the bottom of the pocket. Once it reaches the bottom, it keeps the constant load in the material. So it's a constant load on the tool. You're keeping the same size chip the entire time. And as it works into the material, once it reaches a point where it can't keep that same size chip, it backs off the pocket, comes out, you can see it's a little arc, it keeps a constant distance, comes back off the pocket, rapids over, and then comes back in at exactly the same load on the tool. So you're always keeping the same tool load, the same size chip. So if you can control the chip size, you can run at faster spindle speeds. Faster spindle speeds, you're going to transfer the heat, right? You're going to get less friction. You're going to transfer that heat into the chip and pull the heat out with the chip. So therefore, you can run at faster spindle speeds, faster feeds, and faster speeds. So you're going to be able to get the parts off the machine a lot quicker, and you're going to save tool life because it's not going to retain all that heat, especially when it gets into the corner of pockets like this. So if it keeps the same constant load on the tool, and the point where it can't, it backs off and comes in for another bite. So it's going to eliminate any burial in the corners because it always looks at the smallest bite it can take until it finishes that corner. So you're not going to bury the tool. You don't get those load spikes you get in traditional tool paths where it's load on, load off. Excuse me. It's always the same load on the tool and always the same chip size. So adaptive clearing is a really good clearing tool path for getting those chips out really efficient. Not great for finishing, but really good for clearing, for roughing. Okay, so it's going to save you tool life and get your parts off the machine quicker. So here we're able to do it and wrap that same tool path around the cylinder. So I'm going to post out that code. Let's take a look at it real quick. So I'm just going to post out that operation because that's what I had highlighted. Post out, save the code. We're going to update. We're going to overwrite the one we had before. And as I take a look, it's going to go into that pocket, but you get that constant A-axis rotary axis motion as it helixes into the pocket. You got X, Z, and A. And it's updating the feed rates to keep that same engagement the entire time. So as it goes down, this is just a helixing into the pocket. And again, you can always change your tolerance to make sure you're getting the optimal load. And down here, as it's in the pocket, you see that X and A axis motion. So you're getting simultaneous rotary and linear motion. Okay, so as it cuts that pocket and you say, all right, well, I like the way it's doing that. I want to get that 4 more times around the part, including this one. I have to make another pattern. Well, no, you just click it and drag it and put it in the pattern we've already done. And now we have indexing holes as well as all the pockets getting done quickly and easily. Okay, so that's using the 4-axis wrapped. I'd like to finish this up with a contour. So I'm going to go in to do a 2D contour real quick. 2D contour. I'll select the same pocket. Doesn't have to be the same pocket, but I'll select the same pocket. Again, I'll use the same tool, but if I don't change anything in my geometry tab and I select the pocket, it projects it down into a 2D plane, normal to the Z. What do I have to do? I have to turn on Wrap Toolpath and tell it what the cylindrical size is. Right? I want to drop down to my heights. I want to go, let's say, again, I'll go a 1/10 or 100 thousandths into the part, into the pocket. Okay. Oh, let me see what I did for my tool here. I used a drill. So I'm going to change that back. I don't want to use the jobber drill. I want to use the end mill. So I don't know why I chose the drill, but that would be interesting to try to finish that up with a drill. It would be ugly on my machine. So I'm going to say okay. But it gave me a warning, and that's pretty good. I got a warning that I had a drill trying to do it as a mill operation. So now I have this contour to clean it up, right? And so I can simply add that again to the pattern. Just drop it into the pattern, and now I have a pattern of my drills, adaptive, and my contour for cleaning. Now in my pattern, I can tell it. I can edit this pattern. I can say order by tool. So if I want to do all the drills first, and let's say I'm doing a rougher with the adaptive, and then I'm doing a finisher with the contour, I can choose it to preserve all those tools so I can minimize tool changes. I can also do it and preserve the order of operations. So I can say drill first, adaptive, then contour, index, drill, adaptive, contour, index. You could do it that way as well. Or I could do it, yeah, I guess, an order of operation. And that's exactly what it's doing here, where I can preserve the order that I have in the tree here. So it's really flexible in the pattern to be able to do that. So now, of course, if I go and highlight the pattern, post out the code, I'm going to have all of those operations in the code that I can run on the machine. So, and I'm realizing, Nigel, that we're right up on top of the hour. I wanted to kind of jump in a little bit more, but I think this was this has been a lot of good information for people who haven't really worked with indexing inside of Fusion. But hopefully, this really highlights the differences between the standard product. And I wanted to highlight your ability to do the indexing with drills and be able to post out that code and be able to set patterns up so that you can wrap around the part. Again, it doesn't have to be a cylindrical part. You can always do this on, like, say, a two-sided part to save your setups. You just do a top side, rotate it 180, and then do the bottom side. So it really saves you a lot of setup if you can do that on your rotary machine. But I really just want to highlight those simultaneous fourth and being able to do indexing. So I don't know if you guys have any questions. I don't really want to go too far past the time, but I hope this has been helpful for you guys.
Yeah, certainly, Wayne, and thanks. We do have a couple of questions, Wayne, but while I'm asking these questions, if you want to just throw that thing in a simulation real quick, hopefully it comes across pretty well in the webcast. Just want to see if that does show up. It's showing off pretty well on my end here, just so people understand, like, hey, these are some capabilities in there for the sim. While we're answering a couple of questions here, first question. Does importing things like inventor models remove the parametric and smart feature control? If so, with existing Fusion models, can they be updated with a revised external CAD model and retain associativity? Or at least maintain the CAM data and prompt the user to reassociate? I think I can answer half of this question. Just correct me if I'm wrong here, Wayne. So yeah, so if you do bring an inventor model or SolidWorks or things like that into Fusion, you do lose a lot of that that design intent. So things like features you're gonna lose, but it'll come as what I like to call a dumb solid, kind of like a brick model per se. But just correct me if I'm wrong here, Wayne. Something that the Fusion development's working on is something similar to AnyCAD and Inventor in Fusion. So you can maintain a link to that original file. Do you know if that's gonna affect CAM at all, Wayne?
It does, and there's a couple different ways. So what I would do, if I'm going to work with models that I import, and you can upload a lot of different types of models into here. So like you said, you can do inventor files, we can do Pro-E files, native files. You can bring inventor files, and you're correct. When you bring them in, they don't retain the parametric history, which is okay. But one thing you can do, and this is a bit of a tip here, if I uploaded a model, let's say I uploaded this adapter from Inventor, and it comes across, and in the model doesn't have any feature tree or history, it has a body. And of course, I can always go in and make changes to a body. I can modify this, and I can grab this face like this and stretch it out. You can always do direct modeling to that body, and then save the history going forward. Now, with that said, if you uploaded a native Inventor file, and you bring it in and you add CAM toolpath to it, you can right click and import new version. So if the inventor file changed and has some new features added to it, you can import that new version into Fusion. It'll come in as the latest body. You won't have the features, but it'll come in with the updates. Now, once you do that, it will not retain the CAM on the part. The CAM will go away because the CAM is no longer on the part. What I do is I'll bring the part into an assembly. Bring the part into an assembly, and I can do that here. If I did like a new part, I'm just going to File, New Design, and I'm going to bring this part, I'm going to say Insert into Current Design. Oh, I have to save it first, so I'm going to save it. We'll keep it as untitled, that's fine. Now, I can import that uploaded part, and I can insert it into a design like this. And it should come in as a linked part. You see that link right there. Now, if I add 3D toolpaths to this part in CAM, and then later on the part updates in Inventor, and if I right-click and import new version, it'll update inside of the assembly, and all the CAM will remain.
So it does work. There's for it. That's awesome.
All the toolpaths will remain. They'll update automatically. You'll have the new part from Inventor, but it'll be inside of this assembly, if you will, the composite part.
Nice. I personally did not know about that workflow. and that'll help me a lot. So
Yeah. So I often tell people when you're working, I like to make a version of the part with, like, if I did something like this Kurt template here, this Kurt vise, right? I download the vise, or I download the fixture. If I have my chuck jaw in here, I would have that set up as an assembly. So if I'm doing milling, what I would do is I'd have my rotary table in here. So I can see the rotary table, especially if I'm going to be close to it. I can see if I'm going to hit the jaws anywhere. But it's good to do. It's a good way to mimic what's going on really in your machine and save that table. Like if I brought in the vise and that's what's on my machine, save that as a template. Because then you can put your toolpath in that template. You can just drag your part in. You're already oriented. You already have your G54 set up. You might even have some tools in that template. You just apply your toolpath and you're good to go. So you can reuse a machine template in an assembly. And by doing so, when you import a part into that assembly, all the toolpaths will update automatically. If you're using 3D toolpaths, that is. So hopefully that helps answer the question.
Yep, and yeah, this definitely showed me a workflow that I didn't know of previous to this. So that's definitely a super awesome tip. Let's go here real quick. George asked a question. He just made a comment here that when you did model this part parametrically, Wayne, when you did the offset planes from the, it looks like the XZ axis there, out to draw the pocket and the holes, you did the offset plane at a fixed distance. In regards to doing that offset plane to a point at the outside of the diameter, he just mentioned that might be a better case because if, say, for example, this thing does change in diameter, that offset plane might not be in the right place. It might be like on the inside of a part. And that is totally correct in this case. But if you already know you're going to be working with a stock in this size or a tube in this size, then it's not necessarily necessary. Hopefully you're following, Wayne.
No, I am. I think the suggestion from the gentleman is totally right. I think that's the right way to do it. The more you can make associativity between your planes and your sketches, the better. But again, it all really depends, as to Nigel's point, that it's your design intent. So
Certainly.
if you have an intent that your design may change, perhaps you have a family of tubes in different sizes, by all means, make them associativity. If you do adhere to a specific stock, it's okay. It all depends on your intent of your design. Each way works. But I would agree with you. If we're going to change this model and the design and the diameter does change, it will be associative with that plane. So yeah, that's a good way to do it. And I would agree with you. Yes.
Yeah, certainly. Yeah, especially if you're making multiple iterations of this at different sizings, that'll make it a ton easier. You're gonna have to do a lot less rework in that case. Let's answer a couple more questions here. Looks like, let's see here. For sheet goods, are there any integrated part / profile nesting functions in Fusion 360?
So nesting isn't there yet. We do own the True Nest product. But I can show you in some quick way that we could do something like this. Let me go and I'm going to take this part out of this, and I'm just going to really quickly show you on this plane. I'm going to draw up and sketch up a part, right? So if I did something like this, I'll create a sketch and I'll sketch a simple rectangular part like this. I'll put it here. And I'm not really worried about the dimensions. Stop the sketch. Now, if I wanted to have a sheet of a part like this, and I wanted to do a contour, and I wanted to have a sheet of those contours, and this is just simplified. If I go into my CAM, actually, let me model this real quick. It'll make it easier to show. Let me create this, and I'll make a simple. Now, in setup, in CAM, what we can do is, let me turn off this origin. We can do something like this. So if I did my setup, and I know that this is going to be on a sheet, like, a 4x4 sheet, right? In my setup, what I would do something like this. I'd set up my stock, right? And I would do a fixed size box, right? And I would say, this is going to be, 48 inches, right? And I would have this offset from X minus, and I would have this be like 0, right? And then I would do something like this. And you don't have to do it as the stock like this, but I'm just kind of showing you. Let's say it's 4x4. And I'm going to set this by Y0 and an offset of 0. Actually, I'm going to do it the other way. because it makes more sense this way. And of course, if my stock doesn't have to be 1 inch, I can make this a 1/2 inch stock, whatever. So all I'm doing is I'm setting up my stock around a single part, right? You can of course import, and I would suggest making an assembly of your table if you have a router machine like this. Set up and make it a table, and you can just bring your parts in and drop them in there. Okay, so let's say we did, we'll make it 3/4, and then I can have this offset from the bottom like that. And I want to put my origin right at the bottom corner here. So I would do something like a stock box point, and I would grab the origin like right there. So now I'm mimicking my router table. And let's say I want to make a bunch of these parts. I want to contour this and then make a pattern of those. So I would simply do a quick 2D contour like this. Let's say I grab a quick tool, grab a 1/4 inch flat, and I'm going to make a contour around this part like that. And now I want to be able to make a whole sheet of those parts, right? So what I can do is this. I can go up to pattern. I can make a linear pattern like this. I could say direction 1. I can choose the direction, let's say, off of my origin, right? You could do it this way. And I want to say everything along the x-axis. And I want to have a spacing of, let's say, 3 inches between them, right? And I want to make 10 of those. I guess that'll fit in my 48 sheet, right? And then I can say an additional direction. And I can say that's going to go along my y-axis. And I want to make also make them 3 inches apart. And I'll make another 10 of those. I think that'll fit if I do my math. Not that I'm not going to go off the sheet, but I just want to give you an idea that you can do this. Yeah, we definitely have plenty of room. So, I didn't really give much thought into covering the sheet, but we can do that. But that's the idea. So now I can pattern those to get that same toolpath to cut along that sheet. So if I go up and simulate this, I can see that I'm going to be able to get a bunch of blocks cut out of this sheet like this. So It's not really nesting. It's a way to pattern that you can get multiple parts. You can do this with any toolpath. You can pattern any toolpath that you have, pockets, tap, drills and taps. You can pattern any toolpath that you have available. And so it's just a matter of setting it up that way and then doing a pattern. So there's not really true nesting. In other words, it doesn't take an assembly, flatten them out, and then put them in the most optimum way for cutting them out. We're not quite there yet, but it is on the milestones of our developers to add true nest, the ability to nest inside of Fusion, but we're not there today.
Yep, and that's something that I realized that the Fusion team is super transparent in with the Fusion roadmap. So if you don't already know, people who are watching this, there is a Fusion product roadmap that Wayne's like hovering over right now. That kind of tells you what is on the mind of these developers. In contrast to something like Inventor or AutoCAD or even SolidWorks that do a big yearly release, the Fusion team does something a little bit different. So anywhere between 4, 6, 8 weeks, they release a new version with new functionality. Something that's a lot different than a lot of the other tools that we do see today. Some traditional like software releasing.
I would highly recommend checking this out. Go into this little help icon up here. And go to product roadmap, and you can see what's going on with drawings, what's going on with nesting, with CAM. You can see what's up and coming with modeling and direct modeling. So it's a really great resource. And as Nigel had said, the developers that work with Fusion and in Autodesk are very open, and they share a lot of ideas, and they have a clear path on where they're trying to bring the product, and it's just amazing. And so we get to see things like that, and we get to know what's up and coming and know about TrueNest and know that we're going to have nesting in the near future. It's just that today, this is the way I would set it up to work with patterning.
Certainly. All right, then I think that's everything. There are some other questions that I'll take offline, Wayne. I'll go ahead and forward some of those questions to you as well. But for now, I think that's all the time we have for today. If CAM is something you want to see more of, if Wayne and other of the HSM experts at Autodesk are more that you want to see more of, please let us know, and we can schedule accordingly for something like this, if that's something that interests you and your team. So with that, I'd like to thank you, Wayne, for being here today with us.
Yeah, absolutely. Thanks for having me.
Definitely. Wayne's one of the first people to have done multiple webcasts from us from Autodesk, so that's really cool to see as well. Definitely, we'll see you all next week. Next week, we're going over I can't speak this morning. It's a pretty elementary AutoCAD thing. It's going to be AutoCAD 101, the layer manager. So best practices using layers and the layer manager in AutoCAD. We'll be going over that with one of our application engineers here, Yvonne, and it should be a great show. So Wayne, I'll follow up with you with some questions that I have outstanding. But beyond that, I think we should be good to go. So thanks all for being here, and Wayne, we'll see you soon.
Yeah, absolutely. Again, thanks for having me. And I'm going to tune in for that other webinar because I used to use layers like crazy. So I think it's going to be awesome.
Certainly. And we'll see you all next week, guys, everybody. So you have a good one. Bye.
Thanks, guys. Bye now.